Hello student. In last class we have discussed about effect of rotation of the earth on the acceleration due to gravity g, and we have derived the formula for this. G at any latitude is given by g minus omega square r cos square lambda, where lambda is a latitude. Right. Now we have to discuss about gravitational potential energy. So our topic is gravitational potential energy. Actually, what is first the question is, what is potential energy, gravitational potential energy? Actually, simply potential energy is the energy possessed by any body due to change in its position or configuration. Now our topic is gravitational potential energy. So simply it is the energy possessed by any body due to change in its position with respect to gravitational field, of any planet or any heavenly body. So here simply gravitational potential energy is a work done due to change in its position against any gravitational field. So its proper definition we can write, it is the amount of work done in bringing a body from infinity to a given point in gravitational field of other. So it is the amount of work done in bringing a body from infinity to a given point in gravitational field of the other. So now let us derive the expression for gravitational potential energy. So suppose first we draw a figure. So suppose here it is Earth, and it is its center O, and suppose its radius is r, and we want to calculate the potential energy at point P. Suppose its distance from the center is small r. So as we want to calculate gravitational potential energy at point P, so from the definition we can say that the work done, we have to calculate work done in bringing a body from infinity to a point P against the gravitational field of this planet, which is Earth, and suppose its mass is capital M. So body is at infinity, and we have to calculate work done in moving a body from infinity to a point P. So from infinity to a point P. So to calculate the work done, suppose here the small element which is dx, and this is point A, and this is point B, A, B, and the distance of A from the center of Earth, it is small x. So now if we want to calculate work done, so first, as we know that work done is equals to force into displacement. So first we have to calculate force. So suppose the body is at infinity, and we are suppose it is at a point, and the force on this body due to earth will be F equals to g m, which is mass of earth, small m, which is mass of object, upon x square. It is the force experienced by body when it is at point A. So it will be gmm upon x square. Now work done in moving through very small distance dx will be it can be written as dw equals to f dx, means gmm upon x square into dx. So here we have write this expression for the work done in moving a body from A to B through a very small distance dx. But we have to calculate work done in moving a body from infinity to point P. So we can integrate this value by considering limit from infinity to this point P, means R. So by integrating it, net work done will be g m m upon x square into dx, and limit, we have to calculate work done from infinity to that point P, and infinity, so here limit should be infinity from P, and the distance of P from the center is small r, so limit is infinity to r. Now by integrating this, here g m m is constant, so it can be taken out. Integration infinity to r 1 by x square dx, and 1 by x square, its integration will be minus 1 by x, limit infinity from r. By putting these values, we get work done will be gmm upon small r with negative sign. So it is the expression for gravitational potential energy in bringing a body from infinity to a certain point P, which is at the r distance from the center of Earth. Similarly, we can get the expression for the gravitational potential energy if body is moved from some distance r1 to some distance r2. So here net work done will be work done when body is moved from r1 distance to r2. It will be simply by this equation. This was the work done in moving a body through a very small distance dx. So if we want to calculate work done from r1 to r2, then we can integrate this expression, and by putting the limit from r1 to r2. So it will be dw from r1 to r2. dw is gmm upon x square dx from r1 to r2. It is net work done. By integrating it again, 1 by x square, its integration will be minus 1 by x, and limits are r1 r2, and when we put these limits, then we get 1 by r1 minus 1 by r2. So it will be the gravitational potential energy when body is moved from some distance r1 to r2. Similarly, if we want to find out the gravitational potential energy when body is moved from capital R means radius of the earth, from the surface to a certain height h. So we can again get the expression for gravitational potential energy. This time limits will be r to r plus some height h. So gravitational potential energy will be when body is moved from R means surface to certain height, means R plus H. This time gravitational potential energy, we can write it directly by this equation, gmm 1 by R plus minus 1 by R plus H. Now by solving this, gmm by R 1 minus R by R plus H. Here Gmm by R 1 minus 1 upon 1 plus H by R. Gmm by R 1 minus 1 plus H by R whole power minus 1. By binomial expansion, when we expand this, we get 1 minus H by R and higher power of H by R. If we consider here that the small h height, it is very small than the R, then h by R will be very small than 1. Then higher power of the h by R will be very less than 1. Then we can neglect the higher power of h by R from this expression. So gravitational potential energy will be Gmm by R into, here 1 will be cancelled out, so only h by R, and as we know that Gm upon R square can be written as small g, so simply m g h. So it is the gravitational potential energy when object is moved from surface to certain height h, which is mgh. So gravitational potential energy is a scalar quantity, and since it is an energy, so its unit should be joule and Cj's unit should be erg. Now next topic is gravitational potential. Gravitational potential energy. Simply gravitational potential. Actually, gravitational potential is the work done in moving a body from infinity to a certain point against the gravitational field, but this time we consider that its mass is unit. So we can define it again: gravitational potential energy associated with a unit mass, or simply a work done in moving a unit mass from infinity to a point against the gravitational field. So it can be written as gravitational potential V equals to gravitational potential energy upon unit mass. Unit mass means divided by mass. So it will be, gravitational potential energy is Gmm upon R divided by small m. So gravitational potential energy will be minus Gm upon R. Or at the surface we can write it as V equals to minus Gm upon capital R. Gravitational potential energy, its unit is, by this formula, work means joule by kg, and it is a scalar quantity. Its unit is joule by kg. So in this class we have derived the expression for gravitational potential energy and gravitational potential. In next class we will do some numericals based on acceleration due to gravity and gravitational potential energy and gravitational potential. Thank you.